Hello everyone, welcome to Math 115 College Algebra. This video lecture is going to be on section 2.1, which talks about the rectangular coordinate system and some basic ideas of graphs, mostly linear graphs. Okay, so the things that you'll learn in this section will remind you how to plot ordered pairs on a Cartesian coordinate system. We'll graph equations by plotting points, and mostly that'll be lines. We'll find the x and y intercepts of graphs. Again, mostly we'll deal with lines. We will review how to compute the distance between 2 points, right? So the distance formula, and then the midpoint between 2 points. Okay, so to start, remember what the Cartesian coordinate system is. It's a coordinate system, let me bring this up a little bit, that consists of a horizontal axis, typically called the x, but you don't have to call it the x, and then a vertical axis, typically called the y, but again, you don't need to call it y. It could be like u and v, right? But typically we use x and y. And they're perpendicular to each other. The center where they meet, this is called the origin of the coordinate system. So this is the origin. And it has the coordinates 0, 0. Okay, so basically, on the Cartesian coordinate system, every location, so wherever I point, can be represented by an ordered pair, right? By an x value, comma, y value, an ordered pair. Let me write that here. So in general, I'm going to have an x value. So we always do like the variable that's along the horizontal axis first, followed by the variable that's along the vertical axis. This is called an ordered pair. So all the x, y's are ordered pairs. And to figure out where to plot the x coordinate, it's how far you are away from the y-axis, like your perpendicular distance from the y-axis. And if you move from the y-axis to the right, that'll be a positive x value. If you move to the left, that'll be negative. And then the y value, that depends on how far your distance away from the x-axis, right, perpendicularly. So if I move up from the x-axis, that'll be a positive value. If I move down, that'll be a negative value, right, depending on where I am. Up is positive, down is negative. So if you notice here, basically the Cartesian coordinate system is split into like 4 different quadrants. So the upper right-hand quadrant, this is labeled quadrant 1. And in that quadrant, the x values are positive, right? Because I'm moving to the right of the vertical axis, of the y-axis. And then the y values are also positive. So x are positive and y are positive. Now, if I move counterclockwise, so I'm going to name these counterclockwise. So I start always quadrant 1, right? And I move counterclockwise. The next one, so the upper left, this is quadrant 2. And in this quadrant, the x values are negative, right? Because I'm moving to the left of the vertical axis, but the y values are still positive. Okay, so if I do x, y, it's going to be some negative value and then a positive value. Then if I move, so I'm going to keep going counterclockwise. Now I'm in the bottom left. This is quadrant 3. And notice here, to get a point in this quadrant, I'd have to move to the left of the y-axis and down from the x-axis. So that means both my x and y values are going to be negative, right, for all those points. And then finally, the bottom right, this is quadrant 4. Usually we use Roman numerals when we do these. And in this case, my x is positive, but my y value is negative. Okay, so here let's practice just plotting a few points on an XY plane or a Cartesian coordinate system. So I'm going to plot these points below. So 1, -3, -4, 2, 0, -4, 3, 5, and -2, 0. And then I also want to determine what quadrants they lie in. Okay, so I have the graph on the next page. Let me bring up the next page. Make enough room here. Okay, so I want to do, I'll write out a little table here. I have my ordered pairs. And I'll list them in a second. I want to plot them, and then I also want to determine what quadrant they're in. Okay, so remember they were, if you look back, 1, -3, -2, 4. Oops, sorry about that. No, -4, 2. -4, 2, that's right. 0, -4. 3, 5. And then -2, 0. Okay, so we'll start with this one, 1, -3. So you always start at the origin. And what this is saying is I want to move 1 to the right, right? My x value is 1, so I want to move 1 unit away from the vertical axis. And then I want to move down 3 units, right? Down perpendicular to the x-axis. So 1 to the right and then down 3. And then I'll plot that point. I'll do it in red here. That'll be this point right here. So this has coordinates 1, -3. Okay, for the second one, -4, 2. For this one, I want to move, so I'm going to start at the origin, to the left 4, right? That gives me a -4, and then up 2. So right there. So let me plot that. This will be the point -4, +2. Okay, 0, -4. So in this case, again, I'm going to start at the origin. I'm moving nothing in the x, right? So I'm staying on the y-axis, but then I need to move -4. So I need to move downward. So right there, that would be the point 0, -4. So that'll be right here. And then I have 3, 5. So I need to go start at the origin, 3 to the right, and then up 5. Actually, I didn't do a large enough grid line here, but it'll be somewhere like right here. So that'll be right, so 3, 5 will be like right here, basically. And then finally, -2, 0. So now I'm going to start at the origin. I need to move to the left 2, but then nothing on the y, right? So I'm going to stay on the x-axis. So that'll be right here. Okay, so what quadrants are these in? Well, the first ordered pair, 1, -3, it's in the fourth quadrant, right? The x value is positive, the y value is negative. It's in the fourth quadrant. How about -4, 2? Well, we can see it by looking at the graph as we plotted it. It's in the second quadrant, right? Again, remember in the second quadrant, the x values are negative, but the y values are positive. So this would be quadrant 2. What about 0, -4? This one is a little tricky because it's not really in a quadrant, right? It's right here on the y-axis. So I'm just going to put on the y-axis. Not really in a quadrant. So it's on the y-axis. 3, 5 is definitely in the first quadrant. And then -2, 0, again, kind of a trick question. It's in between quadrants 2 and 3, right? It's right on the x-axis. So I'll just put on the x-axis. Okay, so that should remind you on how to just plot ordered pairs, right? Plotting points on a Cartesian coordinate system. Okay, now let's review how to graph equations basically by plotting points and then drawing like a smooth curve through some of the points. Obviously we can't plot all the points. There's going to be an infinite number of points to create these graphs, but we're going to plot a few of the points and then we're going to kind of get a general idea by drawing a smooth curve through those points. Okay, and in some cases it'll be simple because the equation will be a line, so we know it's going to be a linear, right, graph. All right, in fact, that'll be the case in this first example. So before I start, let me give you the definition. So a graph of an equation in x and y is basically the set of all ordered points x, y that make the equation true. So for whatever x, y values I have, if it makes the equation true, then that point lies on the graph of that equation. So what we do if we want to make a graph is we typically make a little table. So I have a table here, and I'm just randomly choosing some x values. Okay. Usually I do some like around the center here. So I'm choosing like 0 as an x, then -1, -2, and then all the way up to +2. And then I know the equation, right, that I'm trying to plot here. So it's y equals 2x minus 1. So therefore, if I plug in the x value and I solve for y, then that ordered pair xy satisfies this equation. And it must lie on the graph, right? So I can plot that point. Okay, so first let's actually plug in these x values and figure out the corresponding y values. I'm going to move this up a little bit so I can use the guard here. So where I have an x, I'm going to plug in -2. And then if I work this out, right, 2 times -2 is -4, minus 1 is -5. So what does this tell me? It tells me that -2, comma, this should be a -5, -5 lies on that graph. For the next one, I'm going to plug in -1. So 2 times -1 is -2, minus 1 is -3. So again, the point -1, -3 must lie on that graph. If I plug in 0, 2 times 0 is 0, and then 0 minus 1 is -1. So I know that 0 minus 1 is on the graph. If I plug in 1, then I have 2 times 1, which is 2, minus 1 is 1. So 1, comma 1 must lie on the graph. And then finally, if I plug in 2, that's going to be 4 minus 1, which is 3. So the point 2, 3 must lie on the graph. Okay, so let's plot those points now. So -2, -5. So I'm going to start at the origin. I'm going to go to the left 2 and then down 5. So that'll be right here. Then I want -1, -3. So start at the origin. I go to the left 1, down 3. That's right here. Then I want 0, -1. I start at the origin. I don't move anything in the x, but just down 1 in the y. So that's here, right? That'll be 0, -1. Then if I want 1, 1, I move 1 to the right and up 1. So that'll be right here. And then finally 2, 3, 2 to the right, up 3, right here. So this graph is going to be basically a line that goes through all those points. Right? And it goes on forever. I'll just draw arrows there to indicate that it keeps going. Okay. So again, what this is saying, a graph is kind of cool, right? It's showing you basically all of the points, all infinite points that satisfy this equation, right? All these points here. I only drew 5 of them, a few of them, but all of these satisfy this equation. Okay, for graphs, and in particular lines, there's a couple of important points where the graph crosses the x and y axis. Those are called the x and y intercepts. So if I have let's say here's my Cartesian coordinate system, and I have a line. It could be any type of graph, but I'm just going to deal with the line right now. Then this point right here, where the graph, in this case the line, crosses the x-axis, this is called the x-intercept. So this is the x-intercept. And it has coordinates, I'll call it A, right? It's some value in the x. In this case, it'd be negative just because I happen to draw it in going through the second, third, and fourth quadrants. So it's some value A, comma, but the y, since it's not, going up or down, is exactly at 0, right? So the x-intercept has coordinates A, some real number, comma, 0. And then this point right here, this is the y-intercept. So this is the y-intercept. I'll just do I and t for intercept. And it has coordinates 0, right, because we're not moving in the x, but then it has some value for the y, which I'm just going to call b in general. Okay, so if you have an equation, how do you find those x and y intercepts? Well, you basically set the other coordinate equal to 0, right? So let me write that out here. So to find I'll start with the x-intercept. The x-intercept. What you do is you set y equal to 0 and you solve for x. Okay, so to find the x-intercept, I set y equal to 0 and I solve for x, right? You can see why that makes sense, right? Because remember, this is the x-intercept. The y value is always 0. So if I force y to be 0 and I solve it for x, I'm going to get this a value. This a will be the x that I end up solving for. Okay, and then you can probably guess, how do you find the y-intercept? It's the opposite, right? You set x equal to 0 and you solve for y. So to find the y-intercept, I'm going to set x equal to 0 and solve for y. Okay, so let's try this. So here's an example. I have an equation. Turns out it's a linear equation. And I want to find the x and y intercepts. Okay, so let me write down the equation again. So I have negative 2x minus 4y is equal to 8. And then because I know it's a linear equation, once I have the x and y intercepts, I can graph it because it's in a line, and a line I only need 2 points, right? 2 distinct points to graph the line. So let's start with the x-intercept. How do I find the x-intercept? Well, I have to set y equal to 0. So what does that mean? I go to my equation, and where I have a y value, I'm going to plug in 0. And notice now my equation is just in terms of x, right? In fact, that second term is gone because negative 4 times 0 is 0. So I just have negative 2x is equal to 8. And I can solve this for x. How would I do that? Well, I would divide by negative 2. And I'm going to get x is equal to negative 4. Therefore, my x-intercept is going to be negative 4, comma 0. Right? My x value is negative 4, and we set our y equals 0, right? We started with y equals 0. Okay, let me do the same thing for y-intercept. So for the y-intercept, I set x equal to 0. So where I have an x, I'm going to plug in 0, and I solve for y. So notice the first term is gone, so I just have negative 4y is equal to 8. And then to get y by itself, or 1y, I need to divide by negative 4. So y here is going to be negative 2. Right, so my y-intercept will be 0, comma, negative 2. By the way, the negative 4 is kind of like our A, right, that we talked about before, and the negative 2 is like our B that we talked about before. So to graph this now, so let me create a coordinate system. And I know I'm basically going to be dealing mostly with the fourth quadrant, so I can just draw it like that. I'm going to plot these 2 points, these 2 intercepts. So negative 4, comma, 0. I need to move to the left 4 and then up 0. So that's going to be like right here. And then 0, negative 2, I need to move down. Right, so I need to move down 2. And then 0 on the x and then down 2. So like right here. So the graph of that line is going to be a line that goes through those 2 points like this. And again, it goes on forever, right? It's a line. Okay, so that's really all you have to do to find the x and y intercept, right? Let's do one more example. Okay, find the x and y intercepts of y equals negative 3/4 x plus 3. So start with the x intercept. Oh, let me go back to black. So I set y equal to 0. Okay, so that's going to be, it's going to give me 0 is equal to negative 3/4 x plus 3. All right, how do I solve for x? There's a bunch of ways you could do this. You could clear out the fractions by multiplying both sides by positive 4. That's one way of doing it. Let me just do it this way. I'll bring the constant to the other side, so I'll subtract 3. So now I'm going to write it so that my variable is on the left-hand side. I now have negative 3/4 x is equal to negative 3. Right? I just switched the sides because they're equal, so I can do that. And then to get x by itself, I need to divide by negative 3/4. Okay, so these cancel, right? I have x. And then how do I handle that division on the right-hand side? Well, remember, 3 itself is, you can think of it as a fraction as 3/1. So this is like saying, first of all, negative divided by negative is positive, right? And then you have like a 3/1. And then how do I divide by 3/4? I multiply by the reciprocal, right? So I multiply by 4/3. So that's going to give me just 4 here. So this is going to be positive 4. So my x-intercept is going to have the coordinates 4, comma 0. Okay, what about the y-intercept? In this case, the y-intercept is really easy. Right, so I set x equal to 0. But if you do that, that first term disappears, and you're just left with y equals 3, right? So you've already solved it basically for y now. So y is equal to 3. So the y-intercept is going to be 0, comma 3. Okay, so let's plot this. So I have 4, 0. Let me just draw some tick marks here. So 4, 0 is, I start at the origin, 4 to the right, up 0, so that'll be right here. And then 0, 3, so I move nothing in the x, but then up 3, so that'll be right here. So this graph is going to look like this. A line that goes through these 2 points, yeah. Okay, so again, as a review, to find the x-intercept, you always set y equal to 0 and solve for x. To find the y-intercept, you do the opposite. You set x equal to 0 and you solve for y. Okay. By the way, the reason why it was so easy to find the y-intercept in this case is this linear equation is in a special form. It's called the slope-intercept form, which we'll review in a little bit. But that means that this constant term is what's called the y-intercept, right? So it has the value 0, comma, and then the 3 here is basically the b. So this is like 0, comma, b. That's why it was easy. We could just pick it off. Okay, but it still works if you work it out, right? Because negative 3/4 times 0 gives us 0, so y is equal to 3. So we basically solve for y there. All right, couple more things. Distance. How do we calculate the distance between 2 points? Right? It's like the linear distance between 2 points on a graph. Basically, we have to use the Pythagorean theorem. So, for instance, right, if you think about it, let's focus on the graph that we just did. How far away are those 2 points, the x-intercept and y-intercept, from this previous example here? In other words, what is this distance right here between the y-intercept and the x-intercept? Well, if you think about it, right, let me draw this more carefully. You can see sort of a right triangle in here. And that distance is basically the hypotenuse of your right triangle. Right? This distance right here, this is 4. And this distance right here, this is 3. So if we want to find that distance, right, between the 2 intercepts, we can basically use, and I'm sure you guys have learned this at some point, the Pythagorean theorem, right? If we have a right triangle, then it turns out that, I'll write it here. So let me draw this out one more time. If I have a right triangle, so there's my right triangle. And I know the lengths of 2 of the sides. I'll call this A, which is 4. I'll call this length B, which we know is 3. And I'm trying to find the length of the hypotenuse, which typically we call C. Remember, the hypotenuse is always a side opposite the right angle, right? It's the longest side of the right triangle. Then we can use the Pythagorean theorem which says that the length of one leg squared, so say A squared, plus the length of the other leg squared is equal to the length of the hypotenuse squared. Okay, so A squared plus B squared equals C squared. So in our case, right, we have A is 4, right? So we have 4 squared plus B is 3 squared. That has to equal C squared. So this is 16, this is 9. 16 plus 9 is 25. And then to actually solve for C, let me just write it this way. Right, they're equal, so I can switch the sides and put. I want the variable on the left-hand side. To solve for C, I can take the square root, but you have to be careful. It's really plus or minus when you do this. However, in this case, it's a physical length, so the negative doesn't make sense, so we're going to take the positive root. So C is equal to 5. Okay, so basically what we showed up here is that this distance, we called it D here for the distance, this is equal to 5 units. Right, that's the distance between the x and y intercepts in that particular problem. Okay, what about in general? Like, how would you do this in general? So it's basically the same thing, just using a Pythagorean theorem. but let me write this out in the most general way I can. Let's say I have 2 points. I'll call the first point x1, y1. And I'll call the second point x2, y2. Should be a comma there, y2. Let me do that better here. So x2, comma, y2. All right, and I want to find the distance between them. So I want to find this distance. I'll just call it d for now. So I want the distance d. Okay, well, if you think about it, right, you can think of a right triangle, and we can use the Pythagorean theorem. So I actually can figure out this distance that's parallel to the x-axis from there to there, and I can figure out this distance that's parallel to the y-axis from there to there, and then I'll have a right triangle. How do I know this distance? We'll start with the one that's parallel to the x-axis. Well, it's just going to be my x2 value minus my x1 value. And if we're being really careful, have it drawn so that will come out positive, but if the triangle, or if the 2 points were in a different quadrant, this may not come out positive. So it's really like the absolute value of that. We're going to make it positive because it's a length. And then this distance here, from there to there, this is just going to be y2 minus y1. And we'll make sure it's positive by doing absolute values. So if I use the Pythagorean theorem, then I can say that the length of the hypotenuse squared, d squared, must be the length of one leg or one side squared. So that's, I'll use the difference in the x's here, squared, plus the length of the other leg, squared. But because I'm squaring it, right, I don't really need to use the absolute values anymore, right? I can just say x2 minus x1, because I don't care if it comes out positive or negative. Once it's squared, it's always going to be a positive value. So usually what we do is we just eliminate the absolute value sign symbols. Just write this as parentheses x2 minus x1 squared plus, and then y2 minus y1 squared. And then finally, to get d, I take the square root of both sides. So d is going to be the square root of that. It'll be the square root of x2 minus x1 squared plus y2 minus y1 squared. That's the distance formula. So let me box that here. That's going to be important. Okay, but again, it's nothing more than we just use Pythagorean theorem. Okay, so you might get an example like this. We're asked to find the distance between 2 points. So literally what you can do is label the points. It doesn't matter what you label the ones, what you label the twos. Just the first point I see that's written, I'll call the 1, so this will be x1, y1. And the second one I'll call the 2, so x2, y2. 2. All right, so now I'm just going to plug into the distance formula, right? Remember I'll write it one more time. We just derived it, right? This is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So if I plug in, this is going to be negative 11 minus 1 squared plus 9 minus 4 squared. Right? And then if I work this out, negative 11 minus 1 is negative 12, right? So this is negative 12 squared. I'll write it one more time. Notice that it's the entire negative 12, right, that's being squared. So you have to be careful. You want to actually use parentheses there. It's going to become a positive 144 when you work that out. And then plus 5 squared. There I don't need parentheses because it's already a positive number. So then this is going to be 144, positive 144, plus 25. And then if you work that out, that is 169, which happens to be a perfect square, right? So if you take the square root of 169, it turns out it's 13, right? 13 times 13 gives us 169. So in this case, the exact answer is going to be like 13. Okay. Sometimes we'll say, it depends on, if it's just numbers, sometimes we'll say 13 units away, but you can just write 13, that's fine. So D is equal to, that distance is equal to 13. All right, actually, let's do one more practice on this, on distance. What's the distance between these 2 points? Okay, so again, label them. The first point I see, I'll label the 1s. Oops, that should be a 1. And then the second point I see, I'll label the 2. So x2, y2. So if I apply the distance formula, I'll write it out one more time. Remember, it's x2 minus x1 squared plus y2 minus y1 squared. So this will be -8 minus a -2 squared plus, and then 6 minus a -1 squared. Then you got to be really careful with signs here, right? So what's -8 minus a -2? Well, that's going to be -8 plus 2, right, which is -6. It's all squared. Plus, and then 6 minus a -1 is 6 plus 1, right, which is 7 squared. And then this will be 36 plus, what's that, 49. So then D here is going to be the square root of, what's 36 plus 49? 85, I guess. So this is 85. And actually, that will be an exact answer, square root of 85. If you want to estimate it, then you can put that into your calculator, and it's around 9.22. Okay. If you're using MyOpenMath for homework, sometimes it wants an exact answer like this. Sometimes it'll just want like an approximate answer just as a decimal. And so either is probably fine, but it depends. It may ask for a particular form. If it wants an exact answer, you should put in exactly square root of 85. But if it wants approximate, then 9.22 is fine. Okay, so that's distance formula. Really nothing more than Pythagorean theorem. All right, what about finding the midpoint, the middle between 2 points? Okay, so let's say we have, let me draw this out again. Let's say I have 2 points. So I have, say, x1, y1. And then I have, say, x2, y2. Okay, and I want to find the middle of the line segment that connects those two. In other words, I want to find this point right, let's say it's right here, right in the middle. Okay, I'll call it like M. This is the midpoint, M. Right, so this is the midpoint of the line segment. Okay, it turns out, and you can almost kind of see this if you think about it. So we want to come up with the x coordinate for the midpoint and the y coordinate for the midpoint. Well, if you think about it, right, the x coordinate of this midpoint, the x, is going to be halfway between the x coordinate of the left endpoint and the x coordinate of the right endpoint. In other words, it's the average of the x coordinates of the two endpoints. And same thing for the y, right? The y coordinate of the midpoint is halfway between the y coordinate for the first endpoint, and the y coordinate for the second endpoint. So it's going to be the average of the y values, right, from the two endpoints. So let me write that out as a formula here. So the midpoint, m, the x coordinate is really just the average of the x values from the two endpoints. So let me write the x1 first. So x1, how do I find average? Well, I add them up, right? And then divide by 2. It's the average of the x coordinates of the two endpoints. And then same thing for the y. How do I find the y coordinate? Well, it's going to be the average of the y's, right? So this will be y1 plus y2 divided by 2. You guys see that? So this is like the x coordinate of the midpoint. This is the y coordinate of the midpoint. All right, so if you just find the averages, that'll give you the coordinates of the midpoint. So here, let's do a couple of examples. So find the midpoint of the line segment with endpoints -2, -1, and -8, 6. Okay, so first label them, right? Again, it doesn't matter what you label them. I'm going to call the first one, I'll call the ones. So this is x1, y1, and the second one I'll call it 2's. x2, y2. So if I want the midpoint, well, for the x value of the midpoint, it's going to be the average of the x coordinates of the two endpoints. So what do? I take x1 and x2, add them together, and then divide by 2. Then I do the same thing with the y values. I'm finding the average of the x and the average of the y's. Oops, this is plus. So this will be y1 plus y2 divided by 2. All right, so what is that? Well, if you work this out, -2 plus a -8 is -10 divided by 2 is going to be a -5. And then for the y, I have -1 plus 6, that's +5, divided by 2 is 5/2. Okay, so that would be the location, that's the ordered pair of the point of the midpoint of that line segment. By the way, if you want, you could write this in terms of decimals too, right? I could also write it as -5, comma, and then 5/2 is 2.5. Okay, let's do one more. So this one says the diameter of a circle has the endpoints -1, -4, and 5, -4. Find the center of the circle. All right, first of all, let's see if we can draw this. So I guess I'm going to be like in the fourth quadrant mostly. So I'm going to draw it kind of like this. All right, so it has endpoints -1, -4. So if I draw that, -1, -4, that'll be somewhere right here. And then 5, -4. So I need to go to the right 5, 3, 4, 5, and then -4. So that'll be like right here. So we can almost guess at this, right? It looks like the center of the circle is kind of like 2, -4, right? But let's work this out exactly. So it looks like it's a circle with radius 3. So it's going to look something like this if you draw the actual circle. It'll go through something like that, right? So we want to we know that the diameter has those two endpoints, and we want to find the center of the circle, right? We want the midpoint, which is going to be, basically, the center of the circle is going to be the midpoint of the diameter. Okay, does that make sense? So because we know these two values, this is -1, -4. I'll call it x1, y1. And this one is 5, -4. Call it x2, y2. Then we can find the midpoint, right, by using the midpoint formula, and that's what we want. That is going to be the center of the circle. Okay, so let's plug in. So midpoint is going to be x1 plus x2 divided by 2, right, the average of the x values, and then the average of the y values. -4 plus -4 divided by 2. Okay, so what's -1 plus 5? That's 4 divided by 2. That's going to be a 2. And then -4 plus -4 is -8 divided by 2 is still -4. It makes sense, right? Because we're still going to remain right on that horizontal line there. And that's what we guessed, right? So this point right here, the center of the circle has coordinates 2, -4. All right, great. So next time we'll start looking at linear equations, so more carefully linear equations in one variable, and then like solving linear equations. I remind you how to do that. Great, thanks.